All right, so today we'll be looking at the 2013 AP Calculus AB free response question number 6. And it says, consider the differential equation dy over dx, which equals e to the y times 3x squared minus 6x. And let y equals f of x be the particular solution to the differential equation that passes through the point 1, 0. So, looking at question part A, it's asking us to write an equation for the line tangent to the graph of f at the point 1, 0, and to use the tangent line to approximate f of 1.2. So first, we have to state that dy dx at the point xy is equal to 1, 0. So after this, the first thing you have to do is find the slope. And we already have the equation for the slope, which is dy over dx. dy over dx is the same thing as the derivative, which is the same as the slope. So in order to find the slope, we can plug in this point right here into the equation that they've given us. So the equation was dy over dx equals e to the y times 3x squared minus 6x. So in order to get the value of the slope, we plug in this coordinate into this equation right here. So the slope m is equal to e, so the y value is 0, times 3 times the x value 1 squared minus 6 times 1. So to simplify, you would get e to the 0 is 1 times 1 squared times 3 is 3 minus 6. So this equals negative 3. So now that we have the slope, we can plug our values into point slope form in order to get the equation for the tangent line. So if you forgot, point slope form is y equals m, the slope, times x minus x1 plus y1. So we can plug these values into this equation here. So we have y equals the slope negative 3 times x minus x1, which would be, in this case, the 1 here, plus our y value is 0. So looking back at part A, it asks us to approximate f of 1.2. So in order to get f of 1.2, we have to plug this x value into this equation right here to find the value of f of 1.2. So that would be y equals negative 3 times 1.2 minus 1. So if we simplify this, we get y equals negative 3 times 1.2 minus 1, which would be 0.2. And that equals negative 3 times 0.2 equals negative 0.6. Okay. So this question, this part A, is worth 3 points. So you would earn 1 point if you have stated that dy over dx at the point xy is 1, 0. You would get another point for finding the tangent line equation. And then you would get the last point for finding the value of f of 1.2. Okay, So part B asks us to find y equals f of x, the particular solution to the differential equation that passes through 1, 0. So you can, first let's write the equation again. So we have dy dx equals e to the y times 3x squared minus 6x. Okay. So first thing we have to do is separate the variables. So we have dy dx here. So we can get all the y values to the left side and move the x values to the right side. So we can divide by e to the y. So that makes it, and then we can multiply by dx. So whatever you do to one side, do it to both sides. So we have 1 over e to the y after dividing by e to the y dy, which equals 3x squared minus 6x dx after multiplying the dx from the left side and on the right side. So after we have this, we should integrate both sides. So let's first integrate the left side. So the left side, 1 over e to the y, is the same as e to the negative y dy. So using u substitution, you should get negative e to the negative y, which equals, so if we anti-differentiate the right side, we get 3x cubed over 3 minus 6x squared over 2. So we can simplify that to be, negative e to the negative y equals x cubed minus 3x squared. And don't forget the plus c. The plus c is very important. So now that we have this equation, we have to solve for c. So in order to solve for c, we should use the point that they gave us, 1, 0. So we plug in these coordinate values into this equation to solve for c. So we should get negative e to the y value, negative 0, which equals the x value, 1 cubed minus 3 times 1 squared plus c. So we can simplify and solve for c. So e to the negative 0, negative e to the negative 0 is the same as negative 1, which equals 1 cubed, which is 1, minus 3 times 1 squared, which would be minus 3, plus c. So then we get negative 1 equals negative 2 plus c. And then we find that c equals 1. So now that we found c, we can plug it back into this equation here. All right, so that simplifies to negative e to negative y, which equals x cubed minus 3x squared, and c is 1, so plus 1. All right, so now we have to get this y, here by itself. So in order to do that, first we can multiply both sides by negative 1 times negative 1. So we get the left side to be e to the negative y equals negative x cubed plus 3x squared minus 1. And then to cancel out the e, we can use natural log. Natural log will cancel out the e. So then whatever you do to one side, you do it to both sides. So do natural log here as well. And that gives you negative y equals natural log of negative x cubed plus 3x squared minus 1. So we have to get the y by itself, so we multiply by negative 1 again on both sides. So that gets you y equals negative natural log of negative x cubed plus 3x squared minus 1. Yep. So this question here is worth 6 points. This question is worth 6 points. So you get the first point for separation of variables. And so the antiderivatives will be worth 2 points. So if you were able to anti-differentiate here and here, you'd get 2 points for that. And then you have 1 point for the constant of integration, c, if you have c, because you can't forget the c, so you get 1 point for that. And then you get another point for the use of initial condition. So you get 1 point for using the negative one, the 1 here. And then you get the last point for solving for y.